Untitled 2, Chapter 1, Section 7, the linear equalities we did yesterday, how to solve compound linear inequalities. We're going to look at absolute values, equations, and inequalities. So the first thing we're going to tackle is just a review on what is an absolute value. Absolute value of negative 3, many students can recall it's got to be positive 3. Students just say it's got to be the positive, but why is that? What is the absolute value? Because if I have the absolute value of positive 3, it still is 3. It doesn't mean the opposite. It just means the distance a number is from 0. So if we have the number 0, and we look at the number 3 and the number negative 3, both of those numbers are 3 units, 3 spaces away from 0. Both of them have absolute values that are 3. That's the definition. The distance a number is from 0. If you have math within the absolute value symbol, you need to complete the math first and then take the absolute value. Kind of like a grouping symbol. Number 4 is what we're going to talk a lot more about, and we start solving equations here. So the absolute value of x equals 8. So what can this number be? What number can we put in here to make it equal 8? Well, the absolute value of 8, is 8. But we have another one. The absolute value of negative 8 is still 8 units away from 0. So both those have values of 8. So here our x value can equal negative 8 or it can equal 8. We're just not sure which one it is. Either one will make this equation true. Continuing that same thought process, since x could be both positive or negative 8, we have 2 answers. Absolute values always give us 2 answers. So if we look at this next problem, set up the same. This box, the absolute value of this stuff in here, is equal to 8. Since the absolute value portion is equal to positive or negative 8, we can set the absolute value equal to a positive 8 and a negative 8. So we take the stuff, whatever it happens to be inside the absolute value, and we write it twice. Once with a positive 8, and we write it again, we just write it with a negative 8. So we're writing 2 separate equations. It doesn't even matter if what the stuff is. So right here, our stuff happens to be an expression. We still take the stuff that's inside the absolute value and set it equal to 8 and set it equal to negative 8. And then we can solve both equations. So I'm going to add 2 to both sides. So here if I add 2 I get 10. And here if I add 2 I actually get negative 6. They're not always going to be the same number. Here they are different numbers. We also need to isolate the absolute value first before we write the 2 equations. So we have this portion here that's part of the left side. We want to isolate the absolute value portion. So we first need to add 5 to both sides before we write the 2 equations. So then whatever that absolute value stuff is going to equal 9. So now I'll write 2 different equations. The stuff that's in the absolute value can equal a 9 or it can equal negative 9. So now we need to figure out what's inside that group, that chunk. So 2x minus 7. So 2x minus 7 equals 9, and 2x minus 7 equals negative 9. So if we add 7 to both sides, we get 16. On this side, divide by 2, x is 8. On the other side, if we add 7 to both sides, we have negative 2. Divide by 2, we get negative 1. So we have 2 solutions here for this absolute value equation. Extraneous solutions. So if we're solving this equation, this absolute value equation, we still have this chunk in here can equal the right hand side. So 3x plus 3 can equal the x plus 9, or the 3x plus 3 can equal a negative of the right hand side. Now notice how I put that whole group in grouping a quantity. It's the negative of this side, the opposite of this side. So if I subtract x to both sides, and if I subtract 3 to both sides, I have 2x equals 6. So the left equation, x is 3. And then the right equation, I can distribute the negative first. That would be a negative 9. So now I need to add x and subtract 3. So we find x is negative 3. So then it happens to be opposite numbers here, and you can plug them back in and check. So 3 times 3 is 9. 9 plus 3 is 12. So this one, if we're plugging it in, we have 12 equals 3 plus 9, 12. That checks. The other side, if we plug negative 3 in, we have negative 9 plus 3, which is negative 6. And then negative 3 plus 9 is 6. Wait a minute here. There's an issue with this. So we can really look at it, plug it in. Negative 3 was what we found the other possible solution. But when we solve this, we're getting a negative 6 equals 6. That's not true. This is not a solution. It's called an extraneous solution. It's when the algebra says it should be a solution, but when you test it, it doesn't work. It's not an actual solution. These are really tough ones to catch. These are called extraneous solutions. And a big hint for this chapter, you can kind of see how the x is on both sides. When that occurs, be very careful. So why don't you try these two equations, try solving these two absolute value equations. And yes, I'm going to have you bring these in tomorrow to look at. And part B goes into inequalities. So now we're going to add inequalities to it. So instead of just staying equations, it makes it a little more difficult. So the absolute value of x is the distance a number is from 0 on a number line. I already mentioned that. The absolute value of x is less than a. When you have an inequality, this distance has to be smaller than the distance a. So it's the numbers between a and negative a. If we show that visually, if we put 0 here and we have a to the right and a to the left, negative a to the left, so they both have a distance of a. So this inequality is saying that the distance, because the absolute value of x is the distance, x is, so x is going to be some distance away, a negative x or a positive x. That distance it is away from 0 has to be less than the distance a is. If we take the inequality and we flip it around and make it greater, that distance has to be bigger than a's distance. So we say it's beyond, it's outside. So we can also show that graphically. And so if we have 0, and we have a, some positive distance a and negative distance a, x would be outside it. So x would be further, so a negative x. So these are examples of between and beyond, words I'll typically use to describe those situations. So we have a few scenarios. We've already talked about this one, solving. You set your two equations. The same thing can be true here. It doesn't matter. All I'm doing is changing the symbols, but we can still write the multiple inequalities or equations. So for this one, we could write the two equations, ax plus b equals c, or we can have ax plus b equals negative c. We always have the two equations. The inequalities, when we're writing two inequalities, we still set the same thing, just as the problem states. The next one is going to be a little different. We still have it be negative c, but because we're making this the negative, we actually have to flip the sign. So flipping the sign is a new thing here. We talked about that with inequalities, and we've now combined it with the absolute values. And the same thing is true here with the greater than. You still are writing two inequalities, and you still need to flip the sign for the negative portion. So I could write the first one as is, keeping the greater than symbol, and the second one, I have to flip the sign and then make it negative c. So again, these are between, these are beyond. And I know that by the sign. Where the x is on the left, I have greater than. Where x is greater than is beyond. And it's less than is between. So let's try this problem. First thing we need to do is still isolate the absolute value. Now I can write my two inequalities. So the first one I'm going to write just leaving off the absolute value sign. The next one I'm going to write, but I actually need to flip the sign and make it negative. Now I can solve both of these. So 2x is greater than or equal to 8. And here 2x is less than or equal to negative 10. And then divide by 2. Now we can look at these and try to combine them if possible. The greater than symbol, so we know it's beyond. If I wanted to combine them, I could take this symbol and I can actually flip the other one around. I could write it like this. If I wanted to graph the solutions, so we have x is greater than or equal to 4, and we have it less than or equal to negative 5. So this is again beyond, to the left and right of our endpoints. Some applications, tolerance. We see this in some manufacturing. If you so if we have a drill bit, and if you go buy a drill bit, it'll have a certain diameter. And the diameter it says may not be what it actually is. They're allowed to mess up. If you're told as a manufacturer, it could actually be between 0.62 and 0.63 inches. Then we can write a tolerance for that. So to follow these steps, the first thing is we can write an inequality. 0.62 has to be the least amount it can be. And then it's got to be no bigger than 0.63. Now, real quick, the equal to sign, less than or equal to, it's hard to measure something to exactly 0.62. We actually can't. If you say it's 0.620000, well, what about the rest of it? It keeps going. So you can never measure to an infinite amount of decimal places. So, or equal to in real life is really a little theoretical in measurement. Next step is find the midpoint. So the midpoint between 0.62 and 0.63. To find the midpoint, if you remember, you can add them together and then divide by how many numbers we have, and you'll get the midpoint, 0.625, one you should just be able to see. You subtract the midpoint from all three parts of this inequality. So similar to what we did a couple days ago, we have the three parts. We want to subtract from each of these parts. So if I subtract from each part, I'm going to have a negative 0.005 is less than x minus the 0.625 I'm subtracting from each part is less than positive 0.005. And so when you're writing a tolerance, you'll notice that the negative and the positive values here actually end up being the same. And so we can take those and actually write it into a tolerance. And to do that, we can simplify, or we can say that the absolute value of x minus 0.625 can be less than 0.005. So what this is saying is that the diameter of the drill bit is x. If I subtract the 0.625, the midpoint, the amount off of what you hope it can be, 0.625, can be less than 0.005. You can basically have an error of 0.005. It's also written a lot of times with like a plus or minus 0.005. You can go 5 bigger and 5 smaller then. So you can say like 5 thousandths larger or 5 thousandths smaller than what you meant it to be. If you read the package, your package is going to actually read 0.625 inches. Or really, it's not going to say 0.625. It'll actually say 5/8 of an inch. It would be the diameter of that drill bit. So here are two more for you to try. So you actually have 4 problems I want you to come in done and ready to go on. This is the end of chapter 1. We've solved absolute value equations and inequalities. Make sure you understood those so you can check those off. And then we'll see you tomorrow.